Okay, so today we are going to look at sizing the battery for the solar system. So we shall really put emphasis on knowing how we can find out the size of the battery to use for a certain load as far as solar system is concerned. So in this case, therefore, we shall look at the daily system requirements of a solar system. So in this case, therefore, you have to make sure you put your knowledge too much on the capacity of the battery, the so-called the SOC, state of charge, as well as looking at what we can call the DOD, the depth of discharge. So you have to make sure you understand these particular two things, the state of charge by definition and the depth of discharge by definition. So the state of charge is the energy level for a battery to exist at any point of time. The energy level for a battery to exist at any point of time. The depth of discharge is the deepest discharging level a battery can tolerate. And the capacity that I was talking about is the amount of energy a battery can store, measured in amp hours or watt hours. So as far as solar technology is concerned, our knowledge now goes specifically sizing the battery. So what we are trying to mention is that the daily system requirements are dependent upon the time the loads or the so-called requirements will be on. Note that in practice, the loads are rated in watts. For example, you might be having the loads of 1 watt, 2 watts, or you can as well have a load of 14 watts. So the equivalence section here is that as far as load factor is concerned, we shall add the wattage. And after getting the wattage, then we got to know the power, because power is measured in watts. So in this example, we shall have to put the formula or the power equation. P equals VI. Then in this case, we shall be knowing the battery voltage, but we shall be not knowing the battery current. Or you may be even knowing the battery voltage, and as far as amp hours are concerned, you can get to know the capacity of the battery. But battery is measured in amp hours. The panel is designed in watt hours, or the so-called watt peaks. The battery voltage is dependent upon the arrangement and the number of the batteries. The arrangement of the battery and the number of the batteries. For example, the battery, as far as the manufacturer is concerned, might be rated 12 volts. And the current times time might be 40 or 50 amp hours. What you don't have at the moment is the current. But now that you have the power and you have the voltage, you can get the current that the loads will be operating on. Since the battery is measured in amp hours, you have to assume the time that will be taken for those particular loads to be on. For this case diagram, we shall have to find out the effect of the battery voltage to the loads in comparison to the arrangement. So you have to make sure you understand that the battery current increases with the arrangement of the battery. We have got three arrangements. We have the parallel connection, we have the series connection, and we have series parallel connection. In the near future, we shall have to look at all of those arrangements. But at the moment, our emphasis is to be put on sizing the battery. And this is what will take us to the exact requirement of the arrangement. For this case diagram, any electrical engineer has got to know that the battery current can increase and also the battery voltage can increase. When you connect batteries in parallel, you will have increased the current. But when you connect them in series, you will have increased the voltage. So in series, current remains the same, but voltage increases. In practice, it is practically understood that the battery current will be smaller or will remain the same when batteries are connected in series. Let us get an example of the power in watts. Suppose you have something like 68 watts or watt loads operating on a 12-volt battery. The current that will be required will be 5.66 amps, approximately 5.7. From the power equation, we shall find out that P equals VI. And that's how we are getting the battery current, which we have talked about as 5.7, because you have to get 68 and divide it by 12. So if these loads are to operate for a maximum of 6 hours with the battery not charging, that is in conditions of depths of discharge, in condition when the consumption is being dealt with. So assume you have to use your loads for a maximum of 6 hours. You will have to calculate the current which we have already got. And when you multiply by the time, that is current times time in hours, then you will get amp hours because current is measured in amps. For this case diagram, the result is 34 amp hours. Therefore, the battery that is required is as heavier in capacity as 34 amp hours. But remember, in the market, we don't have all that much current for the battery or that little current for the battery. The battery in the market on the Ugandan standards is 40 amp hours. If you have calculated that your loads are to be on for only 6 hours and all the loads are taking 5.66 amps say per minute, it will simply implies that the time that will be taken for that battery to be off is an approximately of 34 hours. Therefore, the battery of 40 amp hours or 50 amp hours will be required for this particular system. In this case, we shall be neglecting the consumption during the day, because you know that the loads can as well operate on the panel voltage. Therefore, consideration of the consumption here is negligible. Selecting the size of the battery therefore requires any electrician or electrical engineer to practically know the loads in watts, the voltage required, as well as the time that they will take. The first factors will give you the current, and at the end of the day, you will simply get the amp hours. For this case, therefore, the amp hours will be approximated to the market values. That's when you will get the size of the battery that you need. So we have got a question here. Suppose a customer have got 4 1-watt loads operating on 12 volts, then 8 2-watt loads on the same voltage for 20 hours, as well as 42 watts television operating on 19 volts, and a fridge on 21 volts with the power of 60 watts. The previous arrangement, which is for 20 hours, will not be the same as the arrangement of the power circuits, which will operate for 6 hours. Finding the system voltage therefore for these loads will require one to be technical. Hence, you have to remember that voltage will remain constant in one section, but on the other, voltage will have to increase. So the loads in part A are lighting loads, and the loads in part B are power loads. When you put the calculation as far as voltage is concerned, for 1-watt loads, which are equivalent to 4 in a number, they will give you 4 watts. And the 2-watt loads, which are equivalent to 8 in number, will give you 16 watts. Therefore, in this case, when you add 4 plus 16, you'll get 20 watts. Remember that these ones are lighting loads. They are operating on 12 volts. Therefore, you'll find out that from our power equation P equals VI, we can easily get the current, which would be equivalent to 20 divided by 12, and this will be 1.7 amps. Since these loads will be operating for 20 hours, it simply implies that 1.7 amps, which is the current, times 20 hours, which is the time, will lead us to current times time, which would be equivalent to amp hours as a unit. Therefore, in our calculation, when you get 1.7 times 20 will be equivalent to 34. And this will be the amp hours. So in the market, we have got 40 amp hours as well as 50 amp hours, which is the nearest. Therefore, here you have to make sure you round off. For section B of the power loads, we shall be having 19 volts and 21 volts respectively. So when you add this voltage, it will be equivalent to 40 volts. Therefore, these loads will have an accumulative factor of 40 volts. But since there are two loads, you divide by 2, and therefore you will get 20 volts. So in this case, therefore, when you go to the market, you will not find a battery of 20 volts. You will only get a battery which you can add to another. For example, let them be 2 each of 12 volts, or they can as well be 4 each of 6 volts. But consider the amp hours, which we have not calculated at the moment because we don't know the current. But for this particular section, we shall find out that when you calculate the current times the time, you have to make sure you first assume how much time these rods will be on at the same time. That is the fridge and the screen. Then after the time, after getting the time, you can calculate the time, or you can assume the time. So for example, if we assume that the fridge and the screen will be on at the same time for 6 hours, that simply implies that you have to make sure you multiply the time with the current, whereby we have calculated using the power equation, and we found out that the current is 5.1 amps and the time is already mentioned, which is 6 hours. In this case, we shall find out that we need 30.6 amp hour battery, but 5.1 times 6 will be equivalent to 61.2 amp hours. Therefore, in the market, we shall not find the battery of 30.6. We can have the battery of 40, 50, 60, 75, 100 etc. But since these loads are resistive loads, we have also to put a factor which we call a percentage error, a factor of 10%. That is after calculating. So when you calculate at the moment, you'll find out that the current will be 30.6 amp hours, and that current is the one that will be required to be derived from the battery. So since these ones are resistive loads, we shall put a factor of 10%. So we have to put 10 out of 100 times 30.6 plus 30.6. Therefore, the battery current in amp hours will be 33.6. But remember, the loads being 2 in number and being resistive loads, we shall have to multiply by 2. This simply implies that if there are 4 loads, whether they are resistive or not resistive, but call them the power circuits or the power loads, you just have to multiply by 4. Therefore, for this sector, we shall be in need of a battery of 61.2, but since we have already put a factor or a percentage error of 10%, it will simply imply that the battery required is 72.3 approximately. But in the market, we have got 70, but this one is 73, therefore you have to make sure you buy 75 amp hours. But to avoid some expectations as far as manufacturers of these batteries are concerned, you may not easily know who did manufacture it. Therefore, you have to look for 100 amp hour battery. Thank you very much. Wish you the best.